I'm going to share with you a little anecdote because I wish I could figure out a way to get even with him. I once did a talk, and I was kind of anxious. The room was filled with people, and I was about to start the talk. And I'll cut this kind of short, but I heard a obscene sound come from the front just as I was getting my roll going, and I thought, oh, that's funny. Somebody brought a whoopee cushion with them, and so I get ramped up again, and I'm going, and then I hear bleat again. And, I thought, oh, okay, that's funny. But then I see all the way in the back of the room, way in the back, there's Don Parker's face, and he's got a remote control device. I don't think I was able to actually resume my talk for a solid 5 minutes. I mean, there was tears in my eyes. But anyway.
We'll give you back, Scott.
Yeah, well, one day when I can pick up something worthy, I will try. Anyway. This guy needs no introduction. Don Parker, with his new Lilliputian-sized computer, will regale you with planetary advice.
I'd like to apologize for the terrible scene we've had this week. Having a sleep deprivation experiment going on. You hear okay there, Mike? Is that all right with the mic? Okay, well, we're going to talk about the same old stuff, I guess, Mars. The apparition is still going on, but I'll give you some of the salient points of Mars in 2005. And, it was supposed to be Mars/image processing, but after watching Tony Hallis earlier and Scott yesterday, and tomorrow you're going to see Sean Walker, I've just decided to take up electric trains after I give this talk and forget the whole thing. Anyway, I guess I'm getting old. Okay, Mars in 2005. Just by way of history for those of you who are smart enough not to be involved in planetary work. In 2003, remember, Mars was going to be the best in 50,000 years and 59,000 years, and everybody got all worked up about it. And this may be even a better apparition because it was 30 degrees higher in the sky. Now, by the way, I forgot, I have to do this. Daniel Versace, I didn't pronounce your name right, but you want to stand up? Where's Daniel? Yeah. Okay, he's considered the Bob Gendler of the Southern Hemisphere. He's from Chile, and the April Astronomy magazine. He's got, So, April Astronomy. He's got a spread in here. It's not Sky and Telescope though, Sean, but whatever. And a zillion pictures. They're just phenomenal stuff. And unfortunately for Daniel, Mars wasn't very good this year because it was low and it was low for you, but for us it was good, and that's all they really care about. Okay. It's not that I'm selfish, but whatever. Okay. Opposition in 2005, when the planets lined up with the sun, occurred on November 7th. The closest approach was just before Halloween, so it's easy to remember these dates. Closest approach was on October 30th, which was, again, right by Halloween. And, again, I don't know why we didn't have any trick-or-treaters this year. Kids just stayed away. I can't understand it. But unfortunately for us, this also occurred. There was a momentous event called Hurricane Wilma that came along and sort of messed up our skies for a while. Now, I am going to do a research project. I was going to do it for Wilma, of imaging during the eye of a hurricane, to see what the scene was like. But the thing came in there during the day, and I couldn't do it. I was just... And they guaranteed me, I don't think Jim Bell is here yet, he's going to give a talk this afternoon, which is going to be unbelievable, on the rovers. This guy, in addition to being a cool guy, he's got some stuff on the Mars rovers that just knock your socks off. But Jim, he guaranteed me that this would be published if I could do this study. It would be published posthumously, but, whatever. Okay. So Mars was pretty close this time. It was a little less than 44 million miles away. And that was 20.2 arc seconds. And for those deep sky observers who aren't familiar with arc seconds, it's a little bitty thing. This is Mars at 20 arc seconds compared to the moon, or a part of the moon, and it's the size of a small to medium-sized crater. So even at best, Mars is still pretty small, and you need pretty good magnification and decent optics to really study it. You've heard, of course, this year that Mars will be the size of the full moon. I mean, it was on the news, right? Okay, so all you do when you hear this, it'll probably be repeated in 2007. You say, well, it's the size of the full moon at 130 power or whatever it'll be then. But the sensationalism here was just unbelievable. It was worse this year than in 2003, I think. I don't know why. Now, Mars comes into opposition about every 26 months. 26 months. And I'm going to do this. Now, I had an animated GIF file, but my 2-pound computer here wouldn't handle it, so I'll just do it by hand. And this was like last August. This was the position of the Earth, which is the... what color is that, Tony? Is Tony here? Oh, whatever. It's too much red. Cyan. Okay, a little cyan, yeah. Okay, and then you go to September, and you see Earth is catching up with Mars, because Earth doesn't have as far to go, and it also travels faster. And here we are in November, and that's opposition, lined up with the sun. But now we got to wait 26 months. Here we go into 2006, and just keep going. We're getting farther and farther away from it. That's conjunction right there, where it's on the opposite side of the sun. And we got to wait a whole nother year. Oh, it comes around, and 2007. This is nice, because when you study Mars, you only have to write a report every other year, so it's good. And there we are. Easy date to remember again, December 24th, right, 2007. And this in my family is a particularly important date, because we always have special treats planned for the grandchildren. Okay. Anyway. I have Tippy Dioria to thank for that one. Okay. Now, not all Mars oppositions are equal, or apparitions. And the reason is that Mars's orbit is very eccentric. It's egg-shaped or whatever. It's much more eccentric than the Earth's orbit. And aphelion refers to the time when Mars is the farthest from the sun, perihelion when it's the closest to the sun. Maybe I'll use the pointer, I think it's easier. Okay, Mars oppositions. Perihelic Mars is about, and you know, I don't use metric and I round things off, so just bear with me here. It's about 35 million miles from the sun when it's the closest it can get in its orbit, and 63 million miles away when it's farthest. That's a difference of whatever, 30-some million miles. I'm very good at math too, and so I mean that's a lot big difference. And here it kind of explains or shows the difference. This is 1980, and these are to scale, and this is 2003. And this shows a couple of things. First of all, a difference in size. We see Mars at a bad opposition or a good one, and the other thing is the difference between film and CCD in 20 years. You know, same telescope, same everything except film versus CCD. So 1980, that's where Mars was, 63 million miles from the Earth, and right near, it was almost as far away as it could possibly get. That's the line where it is the farthest. In 2003, it was 35 million miles away, and look at that, almost the best it's ever going to be. Until when, Dan? You know when the next good one is? We're all going to be dead. Or I will be. I don't know the rest of you, but you know, huh? It's quite a number of years before it's going to be this good again. So our children will see it anyway. This is where it was in 2005, 44 million miles away. And in 2007, it's called an intermediate opposition. So it's not real crummy, but it's getting there, and it's 55 million miles. And with our technology today, it really doesn't make any difference how big Mars is anymore. So this is kind of a nice thing. Now, Mars has seasons like the Earth because its axis is tilted, very much like the Earth's. Ours is 23.5 degrees, and Mars is 25.2 degrees. Not tilted the same direction, but it does have seasons. And again, we'll go back to the aphelic, when Mars is far from the Earth. And you notice that the northern hemisphere is pointed toward us. On the perihelic, like we had this year and in 2003, the southern hemisphere is pointed toward us because of Mars's axial tilt. So for many, many years, the most studied part of Mars telescopically was the southern hemisphere, because that's where you could see best. And it turns out, I think the most interesting parts of Mars are the northern hemisphere phenomena that go on. But anyway, in the next apparition, there'll be less of the southern hemisphere visible, and after that, we'll be looking at the north. Okay, and this just gives you an idea of 2005. Mars has seasons, and we saw the southern hemisphere. It was tilted toward the sun and toward us. Spring, and then just before opposition, it became southern hemisphere summer. And right about now, we're just past the autumnal equinox in the south. So that's kind of where we are now, and that kind of shows what Mars is, the way it's tilted toward us. Now, this is for cocktail parties, okay? You know, you're at a cocktail party, strange bunch of people. You don't really know them. You get in this group, you don't know what to say. This will get them every time. You say, did you know that at opposition, Mars is always one season ahead of the Earth? And you know, then you don't have to worry about talking to anybody the rest of the evening. So, you know, they're just kind of. If that doesn't work, I always use diarrhea is air raid spelled backwards. And, okay. Anyway, well, work it out. Okay. And the other neat thing is that Mars is, well, see, it does work out that way because of the axial tilt. And the pole star on Mars is pretty cool because it's closer to being, it's very close to Deneb. So that's a neat pole star. So the Martians have a nice thing going for them there. Okay, Earth date, November 7th. On the Earth, that was opposition this year. And that's northern autumn here. It's not winter yet, northern autumn. And the Mars date was February 9th or northern winter. So that just shows how it's one season ahead. Southern hemisphere on the Earth was southern spring on the Earth and southern summer, which I just told you on Mars. So we looked at Mars mostly in its southern hemisphere, spring and summer this year. Okay, now I want to get oriented here because I do things a little differently. We don't put, unlike Sky and Telescope, we don't put north up yet. We still kind of go with the classic things, the way things look through a real telescope, which is south up. And the preceding limb of Mars is to the left. Now, by preceding, I mean when you trip over the plug that runs the clock drive, Mars drifts that way, okay? And you know that the south and preceding will not necessarily be exactly lined up with Earth's directions because Mars's axis is tilted a little bit. So, but that gives you an idea. And when you actually make an observation or send in a form, put a little arrow as to where the preceding limb is. Just turn off the drive, and on CCD images, I just make a streak. And that really helps orient people as to what you're looking at. Also, the preceding limb, Mars rotates toward its east, our west. All the planets rotate toward their east and in that direction. And Mars's east is also the evening limb of Mars. And this just gives you an idea of some of the rotations here. As Bill Williams took this series here, it's kind of neat. And but that's the way Mars rotates, and it rotates in a little bit more than an Earth day. And to digress, since I'm supposed to talk something about image processing, I'll see if I can do this. I make these videos in a thing called GIF Movie Gear. Now, a lot of you use the Windows program now, but I just really like this, and I'll show you the program. Fatal error, you, oh my God, no, okay. Yeah, GIF Movie Gear. And there's Williams Mars, and we'll open that. And it's, all you do is you get your JPEGs and you got them centered as best you can and line them up. Put them in GIF Movie Gear in order, and there's your rotation. And you can change the, I don't want to get in trouble doing this, but if I can do it, you can change the rotation rate. And I always like to put in a 10 here because it looks cool. You hit the arrow. Okay, you can change the rate, you can change the size, you can center each frame, you can do, change the order, do whatever you want. And it's online, gifmoviegear.com, and it's, I think they ask you $20 for it after 30 days. It's so convenient because I'm not a computer maven, I just dump the stuff in there and it goes. And it's really great for doing asteroids and things like that. Okay, now let's see if I can do this without getting in trouble. Hey, it came back, okay. There's another example of GIF Movie Gear, and just a bunch of CCD images put together. You can get a complete rotation of Jupiter and its moons and eclipse and that sort of thing. And this I took back in January, it was about a month ago. And there is a story behind this too. I don't want to take too much time here, but I was doing Mars, I was imaging Mars, and I had just gotten a new camera. And I was thinking of imaging Saturn, but I don't like taking pictures of Saturn. Now the reason I don't, nothing ever changes on Saturn. This is the current thought. So every 14 and a half years, I just take my pictures and turn them upside down and send them back in. Well, I mean, it saves a lot of time. I can watch 24, I can watch TV, it's good. So, but this time I took these images, and the reason I did is Maureen, my wife, there she is, she came to me and said, oh, could you watch Caitlin, our granddaughter, for a little while? I have to go to the store. And being the selfish, rotten person I am, I said, oh, I've got to do Saturn. I can't, Now, that's the only reason I did Saturn, so I wouldn't have to babysit, because I was out of SpongeBob SquarePants cartoons. I didn't know what to do with her. Anyway, so when I put the images together, I found these spots, okay? And I made a little animated GIF. There's only 4 images, but it shows these spots rotating. The nice thing is about making movie files, you see things better, and you also, if something is an artifact, artifacts generally don't rotate with the planet, okay? So you know it's real. No, I mean, I'm serious. We get accused of this a lot. Okay, so I sent them in, and those of you who correspond with me know I hate email and rarely look at it. And I did open my email, and there was a message from some guy at NASA at Goddard Space Flight Center, and he was on the Cassini team, and he said that day on the 24th there was the biggest electrostatic discharge they've ever measured on Saturn. And the spacecraft wasn't set up to photograph the planet, and could amateurs please try to take images. So I sent these to him, and he got all crazy, and it's a discovery image. And so it just shows that being a really selfish, miserable person does pay off. Okay. And this is the neat thing about this spot is that 3 weeks later, well, almost 4 weeks later, it's still there. Ed Grafton just sent me this image, and the spot's still going. So it's kind of neat, and you can, in the solar system, still discover things. You really can. Okay, Mars's day, I mentioned to before, is a little bit longer than the Earth's, 24 hours, 39 minutes. So it goes around a little more slowly, and in 1 day of 24 Earth hours, it only goes around 350 degrees. So if we look at Mars the same time every night, its central longitude will appear to back up, go against the way it rotates about 10 degrees every night. And like this, Tuesday, Wednesday night, see, same time. So you're going to see the features more to the east each night. Now, what this means is that it really pays to have observers around the world, because if you're observing the same time every night, you have to wait 36 days before you're going to see the same stuff again. But the guys in Japan are going to see the other side of the planet. And you really need, if you're going to study Mars from the Earth, you need a worldwide network, which we actually have established here. It's called the International Mars Patrol. And anyway, there's our fun bunch. Okay, now, very seriously now, we did have, this year so far, the ALPO has received 5,500 Mars observations. And the apparition isn't over yet, from 96 observers in 22 countries. And this is really a cool thing. This here is Chick Capon, right there, who started this all. He died 20 years ago in May. And that's Bill Douglas, who many of you know is president of Southern Cross for many years. And I have this globe that I got willed by Chick because it has little dots on it. Chick was really big on this. We need observers around the world to study Mars. And he really established this International Mars Patrol, and it's really cool. It's so easy now with the internet. And we have, I mean, people I consider friends. Well, like Eric there in Mexico, and we got guys in Japan and France and England. And you look at the countries we had: Romania, Slovenia. I didn't even know some of these were countries, you know, like the UK. I don't know what the UK is, but anyway. No, and and they're doing great work. This is a gal here from Romania, you know, a little 6-inch telescope and a webcam, just doing phenomenal. She made some discoveries this year, so it's kind of neat. And again, with the internet, it's so much easier than airmail or overseas telephone calls. And so this latest apparition, I think, was an internet apparition. I'm going to show you some interesting websites I think you should. Oh, I'm sorry. Sorry about that. Yeah, I have an automatic link to that, and it just, you know, yeah. Anyway, one, of course, I have to put an ad in for our own group, the Association of Lunar and Planetary Observers, ALPO for short. And we have a website that Rick Hill has made for us at the Lunar and Planetary Lab at University of Arizona. Or just go on Google and put an ALPO, and you'll get something that's not dog food after a while. And you go down here on the web page, and here's all the planets we deal with. You can click on all the various sections. We have a training program, publication section, historical instrument section, just about anything you'd want to do, computing section. It's a nice site. And if you click and go on to the Mars section, oh, the other thing too, we also, each section now, I think, Roger, just about every section has a professional advisor who you know, gives us help. And I hope Jim Bell isn't here, because he's one of them. And this just gives you an idea of the images we put up on the web page. And another site is the Oriental Astronomical Association Mars site. In addition to putting up this site, which is just phenomenal, it has thousands of observations from the last several apparitions on it. We get a printed newsletter every 2 weeks. It's written in Japanese and English. And this just gives you an idea of one of their pages. You can find any observer, any type of observation you want. It's all organized. Yahoo Groups has a tremendous thing now. The images go on there. They're unfortunately bigger than thumbnails, but you can't really blow them up to normal size. But we have a very nice discussion group for Mars on Yahoo, and this year they had 1,400 members. So if you like email, join this group. I mean, it's just, you know, all kinds of discussions. And the neat thing is too, a lot of professionals chime in. Gary Rosenbaum at I think he's still at Lick Observatory, not Lick, down in Tucson. Kit Peak. I think that's where he is now. But anyway, he chimes in periodically with, well, you guys are stupid. No, he says, you know, this phenomenon, because we see these things on Mars. And these guys now, the amateurs today aren't waiting for me to tell them to look at something, because I usually don't know it either. And they're finding stuff on the planet on their images and so-and-so's images. And then they go on the site and they say, you know, wow, that's really cool. What is that? What is that? And then Gary or Jim Bell or somebody will chime in and say, well, we think that's this. And it's kind of neat. It's a real give and take thing. So we've had very active. This is the Yahoo website, and the observations are organized by the central meridian or longitude, and also the new images go in there. And finally, this is something that's been established since 1995. Jim Bell at Cornell University started this for us. He got Jet Propulsion Lab to fund this, and it's called the International Mars Watch website, and where you amateurs send their drawings and their observations. And now, since Jim is doing the Mars rovers, we have Dave Klassen is doing it for us, but we have a professional who's in charge of the site, and he sends out a newsletter every few weeks. And, you know, this is a professional guy who's taken time to do this for a bunch of amateurs, which I think is pretty cool. And so this just gives you an idea. This is Carlos's drawing. We have drawings on there too, a lot of drawings, and really good data. So it's a tremendous repository of data for us and for the professionals. They do appreciate this. Mars observations is about 90%, a little bit more than 90%, or 80% this year of CCD work, meaning video, cold CCD, or webcam. Drawings about 10% still, which is good. And I put other. We have some people now who are doing photoelectric whole disk photometry on Mars, which is a study that is long overdue, because they can tell we're having a dust storm before we can. And also polarimetry, which again relates to the atmospheric conditions on Mars. The big revolution is the webcam. This is the 2U cam, which used to go for $80, and it got popular. It's $130 now. And of course now you can get a really nice little webcam for $1,000 if you want. But nonetheless, this is a great little camera. And the neat thing about it is that the software to run it, at least initially, is free. This is Registax, which is a freeware program, and we use for processing the images. And it's a tremendous service that this guy has provided. And so you just put the images in here and you stack them, and bingo. Now I'll just give you an example, I hope. I'm not real good at this linking stuff. Let's see what happens. Okay, very good. All right, now this is taken a week ago. This is Mars at about 8 arc seconds, and this was with a webcam, Luminara webcam, in really good seeing from my house. And that's good there. I mean, it really got good. You can tell it's really getting good now. So this went on for about 3,000 frames. And the webcam saves this as an AVI file, okay, which is a standard video file. I'm going to stop this because I really get nauseated. And I'll see if I can get back to my regular program. And you saw those frames, right? I mean, some of them were much better than that, but that was an average. Okay, put them in Registax. I stacked about 1,000 of them and wound up with that. I mean, it ain't bad. 8 arc seconds. And so what these webcams have allowed us to do is beat the seeing. These things are shooting at the 50th or 100th of a frame per second sometimes, the new webcams. And even those times of turbulence, you have some very sharp images coming through. And as opposed to film, which requires like many seconds exposures, or even cool CCD cameras, which may be a quarter of a second or so, these things are fast and they allow you to beat the seeing. Here's just an example of Jupiter. See how grainy and it's kind of noisy and all that. And you put it in Registax and you do just a minimal amount of processing on it, just a number one wavelet at 50%, and bingo. And that's the other thing I've learned from a lot of these guys I've been dealing with, is that the less processing, the better, really. And you just don't overprocess this stuff. So whatever. The other things we've been able to do, this is with a 10-inch telescope and a webcam, details on Ganymede, which are real details. Just great stuff. You can get Mars images that rival the Hubble. So yes, that's Olympus Mons there, and there, clouds. Okay, here's a guy, Larry Owens, up in Aliphatta, Georgia, which, with a C-14 and a fairly inexpensive webcam. This is at opposition. I mean, look, he got little polar caps less than an arc second in size. He nailed that. This is some guy named Sean Walker, who 7-inch Mac Newt from the Boston area, you know, with a seeing. They're not noted for their great seeing. And this is, again, it's not just a nice image, but he nailed this dust storm that's coming down here across this area. Isn't that neat? And that's just, you know, simple webcams. Again, nothing really fancy. By the way, Sean is also, I understand he's resigning from Sky and Telescope to take up a career as a successor to the crocodile hunter. Outside our room the other day, we had a attack by the giant lizard, so Sean went after him. Crikey, he said, look at that. Okay. The other big advantage of the technology today is that you can image planets when they're very, very small. I mean, we're getting images of Neptune and Uranus now at 4 arc seconds. Here's Mars taken by Damien Peach over in England back in 2002 at less than 4 arc seconds, and they are good pictures. In 1980, I would have loved to have had a slide of Mars like that at opposition. I mean, here he's doing it, you know, it's just tiny. And again, you're beating the scene because you're doing a very high frame rate. It's very effective that way. Okay, to repeat now, we're seeing southern spring, southern summer mostly on Mars during that 2005. And the south polar cap is one of the things we study because it regresses. It doesn't melt. It sublimes away throughout southern spring and summer. And this just gives you an example here of the south cap. This was actually the first day of spring in Mars on the south. And the cap, you know, surprisingly gets smaller and smaller as summer progresses. And this is midsummer here. It's just a tiny little nubbin. And this is a fellow from the Netherlands who sent us this series. It's just beautiful, Richard Bozeman. Isn't that something? And what's he using? He used I think it's a 12-inch telescope or something like that, and a 2U cam or something disgusting, you know. Again, you see the cap, you know, regresses as the series continues. But I wanted to point out here that people for a long time said, oh, the south cap completely disappears in southern summer. North cap doesn't because it's very thick ice remnant, but they say, the south cap probably goes away. Well, it probably doesn't. Now, the spacecraft have shown this now, but nonetheless, you still don't see it sometimes. And here you don't see it because the south cap is offset 5 degrees in a certain longitude. So when you're looking at the other side of Mars over here, you're not going to see the little cap remnant. And just to show you here the picture, see that this is where it's angled toward. It's about 50 degrees longitude right here. And this is taken at the same time. I don't know who took these, I forgot. But this is just about the same time or same date on the other side. These are two guys who were, you know, one in Japan and one in America. And the cap looks totally different even though it's the same day and same date. So Mars always has some kind of nasty surprises for us. Okay, and the other features of the south polar cap are these rifts that develop. As the cap sublimes away, it breaks up, and you know the geography under the cap, or areography under the cap, is rugged terrain, and so various rifts and splits, and they all have incredibly unpronounceable Latin names, so I won't go into it. These here are called the Mountains of Mitchell, with one L, and these were discovered probably by some guy named Mitchell, and they weren't mountains, they're actually depressions, okay, but the old-time astronomers thought these were mountain peaks that still had snow on them when the cap regressed. And with this stuff, in addition, it's a good test for your telescope. It's also very important to know when these things break off. These are actually, the whole group of them are called outliers. This is, again, is the Mountains of Mitchell here. And this is another little blob, which names I forgot. It's important to know that because one of the studies we do is the timing of the polar cap regression. We've been doing that for about 40 years now. This is one of the things where we found there was global warming on Mars, which the spacecraft have recently verified. With Mars Global Surveyor people. We don't know why, but I suspect it's my Explorer that's causing that, but not sure. Anyway, but this is very important because Mars does have a climate. It has weather, and this is one of the studies that amateurs can do and have done over the years. This apparition, we don't have all the data worked out because there's a lot of statistics involved, but it looks like the cap actually was a little bit bigger in midsummer than normal, so Mars may be actually cooling down a little bit. Okay, now there's another phenomenon here called the south polar hood. When the cap, either the north or the south, begins to regress or sublime away in late autumn, late summer rather, in whatever hemisphere you're dealing with, the cap becomes covered with this hood, this kind of dirty gray hood of clouds, and that's called a polar hood. And this guy just gives you an example of it. This was, I don't know when this was. Oh, it was just recently, 14th of January. And that is the South Polar area. The cap is no longer visible. And you see in blue light, you see this kind of cruddy looking cloud. So these clouds kind of cover over the cap. And it's interesting to study also because its behavior changes dramatically when dust storms are around. And also its appearance, until recently, has been a mystery. The classic interpretation of the polar hood was that you have this hood forming over the cap. During the winter, autumn and winter, the cap is growing underneath this hood because it's cold. You know, there's no sunlight there or anything. And then the first day of spring, or right around the first day of spring, the hood dissipates and here's this pristine, beautiful white cap left. Okay. Now, Clyde Tombaugh years ago said, he was a tremendous student of Mars. And he said, he didn't think that was right. He said what he thought was his knowledge of physics, especially on Mars, was that the hood forms, and then the first day of spring, it condenses to form the cap. And everybody thought, well, Clyde, yeah, okay, old guy, doesn't know what he's doing. Well, this picture was an accident. I took this in 1992, and I forgot to put the infrared rejection filter in. So essentially, it's an infrared green and blue picture. And I said, something's wrong with this picture. Well, it turned out these are named albedo features under the North Polar hood. And if the cap were there, you wouldn't be seeing these things. Okay, they'd be covered with the cap. And 2 weeks later, they were, because the hood went away and the cap was there. This was taken just a few days before the spring equinox in the north. So I showed that to Dr. Tombaugh at a meeting. I presented it, and he was there, and he got all extremely agitated and was really happy about it. And since then, the Mars Global Surveyor has sort of proved this. This film clip starts in February 2005 in the southern hemisphere, late winter. Okay, this is the hood. It just kind of clouds, it's kind of breaking up, looking crummy. See a dull, awful looking thing, nothing under it. And then all of a sudden it starts going away, and bingo, you're going to get a nice bright cap right about there. Okay, and these were also taken in infrared, so they would have seen a cap through that thing. It wasn't there. Because the hood just kind of, it was a crummy looking bunch of clouds, and all of a sudden they went away, and boom. So what probably happened is it condenses down to form the hood. And again, when you're studying Martian climate, it's important to determine what date the cap formation or the cap appearance occurs. And this year it was a little bit late, so maybe Mars is cooling. Okay, and here's just another shot during this current apparition that we did see the named dark features under the hood. Now, which brings me to the next point. I've been talking about clouds and stuff like that. And we have to talk about color filters. So I can do this, I guess, myself here. Okay, we go to a picture here. This is taken with something called film. And here's Mars. How many of you have seen this before? Because you can take a smoke break if you want. Yeah, I'm sorry, guys. Yeah. Well, you don't count, Joyce. You could give this lecture. Okay. All right, here we have the south is up, remember. So that's a south polar cap, north polar cap, and a zit. Okay? Everybody agree with that? Yes? No? Okay. Okay. All right, now we're going to look at this image. Now, this, by the way, is deliberate. Remember I told you we turn off the drive to see which way east and west is, and that's streak it deliberately. Okay, now, this was taken in '86. Now, let's just look at it through color filters and see what happens here. God, I hope this works. I don't look any more of a fool than I normally do. Okay. Well, what happened? Yikes. Wait a minute. Look at there. North polar cap, south polar cap, and a zit. And the north polar cap and the zit pretty much went away, right? This will use a blue filter. Oh, I'm sorry. Well, get over here. I'd hate to have a picture of my rear end on your camera. Okay, can you see that? Blue filter? Okay, now what this tells us, since Mars's atmosphere is largely opaque to blue light, that's not a north polar cap, and that zit is a cloud. Okay, and that thing that we call the north polar cap down here is also a cloud, or the north polar hood. Okay, you never see both polar caps on Mars at the same time. One always has a hood on it. Or it's tilted in such a way that you'll never see them simultaneously. There might be 1 or 2 days when you could, but you might not. So that's another thing you can tell people at cocktail parties to really get their attention. Okay, so we use color filters, and you can use color filters when I know everybody's going to run out there and look at Mars tonight at 7 arc seconds, and you can go to an art supply store and get these little swatches. Huh?
I'm going to see that chart.
Oh, Chuck has them?
Oh, sure.
Oh, okay, good. Get them.
I'm only kidding.
No, do you have them really? I've been looking for them. Edmund sells them for $200, I think, but you know. No, just well, what you do is you put these between your eye and the eyepiece. You don't have to get screw-in filters that cost $50 a piece. You use something like this and just go back and forth. And it works really well. It really does. It brings out the cloud details. The red brings out the surface details because Mars is red. The dark areas tend to be a little bluish green, and that enhances the contrast so you can see stuff. So whenever possible, use color filters when you're looking at the planets, and you'll find all kinds of neat things. It's like drinking scotch. It takes a little bit to get used to, but once you do, nothing like it. And this again just shows clouds on Mars. These are CCD images here from back a ways, 99. And you see the difference, red, green, and blue. Red light, you're seeing surface features. Green, we won't, kind of intermediate, but blue. Difference between red and blue is enormous because there are clouds there. And Mars's atmosphere normally doesn't let blue light go through it. So it's a good way to study the meteorology of Mars. We go into Photoshop and you have CCD images. You got a red one, green one, and a blue one. And you do something that Scott can tell you how to do it, and you combine them, make a color image, okay, like that. Now that doesn't look too good. And this is a problem with Mars. That's kind of what Tony Hallis was talking about, is the color balancing and push and pull and that sort of thing. It's very difficult with Mars and especially Saturn. But you got this ugly looking stuff along here, and there's, it's an artifact and yada yada. So, well, I'm not sure it is, and besides which, I don't like this general cast. So what I do is I take this image, which is the red, green, blue composite, and I bring back the blue image. This was the blue. That's the North Polar hood, and it's clouds and all kinds of neat stuff. I cut or copy and paste this onto the RGB image, and then I go over here to layers, and I use something called hard light, and I can adjust the slider, and there you go. Mars with nice clouds, polar hood. Cool, huh? Yep. So that's the way, that's before and that's after. And I do that with most of my Mars images now. And it just enhances the atmosphere, huh?
What is the slider?
The slider, it's in the layers menu, it's called hard light.
Hard light?
Yeah, it's a layer blending mode. You just pick, and then you got sliders. I mean, sometimes it's too extreme. You can just adjust 50% or whatever percent you want, make it aesthetically pleasing. But in addition to looking nicer, it also has a lot more information on it, which is really what you want. This is back in 2003, same thing. This is kind of what I was getting all the time on Mars, and I knew there were clouds there, so I kind of figured this out accidentally. And see that that's morning limb haze. It's fog, like we'll have tomorrow morning maybe. And that's, again, polar hood with a cold front coming off of it. So, cool stuff. Okay, and as I pointed out, Mars has an atmosphere, it has weather, and a lot of these clouds are called water ice crystal clouds. They're not, there's a lot of water vapor, well, relatively, for Mars there's a lot of water vapor in the atmosphere. And the clouds are made up of water ice crystals, and they tend to form in the spring and summer afternoons over the volcanoes, just like you got in the Rocky Mountains. And in the summer, when you get the heat bringing the moist air up, and it condenses into clouds. They're called orographic clouds. And in the Everglades, we have a similar phenomenon in the summer where you get the updrafts, the moisture from the Everglades, and we get these really beautiful thunderstorms, which scare the hell out of you in the afternoon. So I took this, I was using the the Celestron Next Star, I think it was.
Whatever's the biggest one.
Yeah, right, whatever's the biggest one, I just can't remember. That's Olympus Mons, the 18-kilometer high volcano on Mars with orographic clouds around it. That's an artist's sketch. And the neat thing is, too, you can see these volcanoes. I think the next apparition, I'm sure we will, because we'll have better technology. But that's Olympus Mons there. And these are the other three big volcanoes of the Tharsis Shield, which is Arsia Mons, Pavonis Mons, and Ascraeus Mons. And they're named after classical blotches that the classical astronomers saw these, and they named them after some mythological characters or areas on Greece and whatever, and the names have stuck. Olympus Mons, even though we know it's a monster volcano and should be called Olympus, in the 1877, Schiaparelli said it had orographic clouds on it, so he called it Nix Olympica, the snows of Olympus. It was very poetic, and not knowing that was a real Olympus there. And this is Ed Grafton did this. That's Olympus Mons with a shadow. It's not casting a shadow, but what you're seeing is essentially a phase. It's toward the evening, so the back half of Olympus Mons is in shadow. And big debate. You may have read the editorial that we sent to Astronomy or Sky and Telescope about casting shadows. Well, the slope of Olympus Mons, even a fat guy like me with my cane, I could walk up that thing to the summit without really much problem. It's about a 4 or 5 degree incline. Yeah, it's a shield volcano. And you go out to Mauna Kea, or not, Mauna Loa, whatever it is out there, and it looks flat almost. And if you were standing on Mars looking at this volcano, it would just look maybe a little bump, and that's, nothing to it. So they don't cast shadows, but you can see them from the Earth. And also at opposition, they get real bright. And we noticed that this year, and this is the first time somebody called attention to it. The amateur said, "Oh, Olympus Mons is real bright. It's white. It's like a white dot." And that's the opposition effect, like why the full moon is brighter when the sun's coming right at it, at opposition. Some of these clouds form over the volcanoes and they actually coalesce, form a W cloud or the W cloud, depending on your politics. And this is, again, 2005, we had a little W cloud, but we had a thing called the domino clouds, which is the same thing. You see, it's in the afternoon here, and these clouds are forming over the volcanoes, and they're kind of neat to watch. In the southern spring and summer, we have less of these discrete water crystal clouds than we do in the northern spring and summer. And this is a thing that Jeff Bish and I did a few years ago, 24,000 observations we went through and statisticized the clouds and did all that stuff, which shows you how really sick we are. The northern hemisphere is a very thick remnant of water ice covered by carbon dioxide. And it used to be thought that the southern cap was mostly, well, all carbon dioxide. Now they know there's water in the south too. But the main reservoir for the north is the North Polar Cap. The main water reservoir for the south are the big impact basins of Hellas and Argyre. And they're not on the South Pole, they're just a little bit north of it, so they get the sun first before the South Pole does. The water goes off, and we tend to see these clouds earlier in the southern hemisphere than we do in the north. This is the cloud called Arsia Mons. That's a volcano I told you about, Arsia Mons. And I have a better picture of it. That's the volcanoes, the 4 great volcanoes. That's a much better picture of Arsia Mons. That was taken, I think that was taken with one of the Meade cameras, wasn't it? Okay. All right, and this is a blue light picture from 2003, Arsia Mons. And during this, the clouds stayed there the whole apparition, all during spring and summer. All the other clouds kind of came and went. Olympus Mons didn't have any clouds this year, but Arsia Mons came and went. And we do a little lapse time here. And notice how it's getting brighter and brighter as afternoon progresses. Just like in the Rockies, those clouds start building and getting brighter and brighter. And we got another one here. This was taken this year. Again, Arsia Mons. And as afternoon, as it rotates, it gets bigger and brighter.
Is it taller than Olympus?
No, no. Actually, it depends on where you measure it from, but SCAS Mons, I think, is the tallest, but from the base or something. I can't remember how it is, but Olympus really isn't the tallest volcano. It's kind of like is Pluto a planet, though. I mean, it's from its base, though, it's not the tallest. Anyway, you can see how it's getting brighter. And also notice there's another thing here, which I just noticed. There's a little cloud right on the terminator. See, it just disappears. Wait on the next run there, you'll see it. See that little zit? Isn't that cool? Now, this is stuff you can do with blue filters and fairly simple equipment. Okay, now Mars does always have surprises for us. Even though now we really know a lot of what it's going to do, we can predict the weather on Mars to a certain extent. And one thing I've learned in observing Mars now for 52 years, God, is that it always has surprise. Mars is kind of like eating at a Chinese restaurant. You're never really quite sure. What you're going to get. Okay. Anyway, Mars has dust, okay? And this is, all the science fiction stories you read about Mars. There's a dust storm, it's killing everybody and all this stuff, and it is noted for its dust. And the spacecraft have certainly shown us that it's a very dusty place. It has dust devils that leave little tracks in the sand. Look at that. These are tracks from the dust devils taken by the Mars Global Surveyor. And this is a picture from the Odyssey spacecraft of a couple of them zipping along. Isn't that some? Yeah. They do nice work. So Jim Bell sent me that. I think it's on the net now too. It's just beautiful. Anyway, and this gives you an idea of some of the dust storms on Mars. I mean, this is a minor dust storm that occurred in 2002, I guess. And you compare that in size, it almost would cover the United States. So these are significant things. And here's a real big one. Right there, look at that. That's the coast of Africa, and here's my house, okay? South Florida is a very dusty place. We get Sahara dust over here. And people didn't believe it, but now they've actually analyzed the dust, and certain times of the year we get these clouds of dust coming and depositing in our optics and things. And most of the dust storms, though, you think about on Mars, these big global dust storms. 1971, just before the Mariner spacecraft, Mariner 9, arrived there, Mars, little zit started right there, and in a week it covered the entire planet. And the spacecraft got there, and the thing looked like a cue ball. You know, so I think we wasted $1 billion here. You know, Werner, we have wasted money. Okay. Anyway, these are the romantic storms, but there have only been 10 of them since 1877. These big planet encircling storms, and there's only one truly global one. If you again get into semantics, because that covered the poles in addition to the rest of the planet. So about every 3 Martian years, you're going to get a really big storm. And fortunately for us, unfortunately for most observers, but I like these things. In 2001, we had a real whopper of a dust storm. It was a good planet encircling storm. It occurred at a time when it was just beginning to peak into the dust storm season. This is that cloud study I showed you before. The yellow now is dust clouds. And you notice that unlike the water ice crystal clouds, dust clouds tend to be much more prevalent in the southern spring and summer. And that's probably because Mars is 36 million miles closer to the sun. It's getting more radiant energy and more energy to lift the dust up. So that's when we tend to see dust storms more often. This just shows the dust storm in 2001. This is Syrtis Major, which hopefully we'll see tonight. And see that little streak up there? This is Maurice Valenberti, and I forgot where he's from now. I think he's in Australia. And this is, as the thing progressed here, there was a couple of weeks later, and it eventually just covered the entire planet, and it lasted about 6 months before the planet really got back to fairly normal. So these dust particles are in the micron size range, and they can stay suspended for a long time. In fact, there's always dust in the air of Mars, which is why the atmosphere looks red. This is kind of interesting. This is like the view that Mariner 9 got when it got to Mars. Mars is covered with dust. This is fresh dust clouds right here. And you see that dark thing right here, that little streak? Well, that's called an anomalous albedo feature, which means that you shouldn't be there. It's a dark blotch that ain't belong there. And the reason is you've got the sun is coming from this direction. These clouds are up to, we measured them to 19 kilometers in height, and it's casting shadow on the clouds below. So you'll see these shadows occur. And you see there are 4 zits here, 1, 2, 3, 4. And those are the peaks of the 4 great Tharsis volcanoes poking up through the dust. And that's what Mariner 9 saw. It got to Mars and said, oh my God, it's a cue ball, you know, and they weren't happy. And Chick Capon predicted this storm, and nobody knows how he did it, but he told them that they were going to get one. And fortunately, his spacecraft was like, you know, the rovers, it was engineered so well that it lasted much longer than it was programmed to. After a few weeks, the dust settled, and that's the first time they discovered these volcanoes. They saw these 4 little dots peeking up, and they got a closer look as the dust settled, 4 big volcanoes. So it was kind of neat. Arcia, Pavonis, SCAS, Olympus. Okay. Dust storms are bright and red light. Everybody says they're yellow clouds. They tend to be yellowish, but everything on Mars is bright and yellow light, so we don't use that. If it's not bright and red light, it's not dust, and it has to move. And this year in 2005, we had 4 dust storms between August and November. 3 were localized and 1 regional. The regional one is more than 1,500 kilometers in long axis. So, I mean, again, that's a semantic thing. And they occurred pretty much when predicted. See, this is right on the peak of the dust storm season on Mars. And the first one really would never have been picked up even probably 4 years ago until the advent of the technology of the webcam. And this was just around the South Pole. See that little streak there? That's the beginning of a dust storm. And then it kind of comes down here, almost yellowish, little fingers coming down. Ed Grafton took that. It's like a little hand spreading down. And this is by that guy up in Georgia again, just beautiful. And that just lasted a few days and went away. Yeah, but that's interesting to know. Some of these dust storms we're now seeing they're extremely small. People are picking them up. Here's an example of one here. This is Sylvia, the girl with a little 6-inch telescope, who picked up that little dot, and she noticed it. I mean, I didn't notice it. See that little dot right there? And Mazzatis, who's some really good observers from Italy, also picked that up. And then that developed into look at that streak, 24 hours between this image and that image, and it blew up probably 500 miles. It just went up across Chrysaea, that's where one of the landers is, the Vikings, and right up into close to the Valles Marineris. And then a few days later, it just kind of went away. But this is really neat stuff, and it's stuff that we haven't really seen that much before. Again, in October, we had a really nice storm. Huh? Oh. Anyway, see that? Again, a little dot right there. And in 24 hours, that little dot went up there. And then you see this is the Valles Marineris. This dust went right along the Grand Canyon of Mars, right along and we could follow it. You can see the Grand Canyon of Mars because that's what this dark stuff is, but to see the dust going along, it was really spooky. And then it blew up south more and became kind of more diffuse, and then finally went down here to Meridiani Sinus. So it was just a very large event. And what really happens here is it's not just one dust storm. I really feel, and we're getting more and more evidence, the fact that conditions are right for a dust storm to develop, so it hits. And then it's like Story Musgrave was talking about the lightning storms being boom, 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 it's a whole chain of them. And I think here the conditions are right, so we got all these, I call them niduses of activity start off, and the dust, they follow suit, and then the whole thing sort of coalesces together to form a dust storm. Ed Grafton did these, and this is just gorgeous. Look, you see the Valles Marineris there? Just going along. This C-14 with a old ST5 camera, I think he used. And then it kind of became very diffuse. It lasted, a couple of weeks. And Rolf Meyer took this. This is of the same storm, but look at that. It's just 3 images, but it really shows how that thing expanded over a period of about 4 days. It started there, that's number 2, and that's number 3. Isn't that neat? Cool. Okay. The final storm we had was not very long lived, but it was very impressive. It sort of just exploded onto the scene. It started October 22nd or 27th. Again, pretty much in that same area. This is the zero meridian of Mars. It's called Meridiani Sinus. And within 1 day, it just became this really increasingly ugly spot, went up there. And a couple of days later, actually occluded Meridiani Sinus. You didn't see it anymore. And you see that, and then it became very diffuse and kind of went away. So that was the history of the dust storms in 2005, and everybody was happy we didn't have a global, except for me. Probably in Dan Troiani, who likes them too, It's an acquired taste. And finally, amateurs have now not only seen, but imaged the moons of Mars, Phobos and Deimos.
Cool.
Oh yeah. And this guy, I forgot, I can't remember, I should have looked up the telescopes, but the data's back in Miami, and I really didn't want to drive up there this morning to get it. But again, it's a telescope that's well under 10 inches in aperture. And this is his image of Mars, actually, he took with a webcam to show you. This is grossly overexposed, because it has to be. But you'd fit this little image inside that to give you an idea of the distance scale. And Adrian made a nice little lapse time for me. Isn't that neat? Yeah. And that's over, not very long, it's about 40 minutes, 30 minutes actually. So they really hustle along. So. And I have one other picture, which is probably better. It's the first annular eclipse we've seen from Mars. The Odyssey took this of Phobos going across the sun.
Oh, wow.
So, the spacecraft are still, they're just doing an absolutely phenomenal job. And I'm looking forward to when Jim Bell comes and gives his talk. He's been one of our mentors and supporters, and we have a lot of these professionals who have just helped us tremendously. Jim is in charge of the color imaging of the Odyssey spacecraft. This is, the Odyssey, the Opportunity lander. And hold still, Larry, it's taking another picture. Anyway. Now, one other thing. Tonight we're all going to rush out to the field and look at Mars. And this is what you're going to see. You're going to see Mars. If south is up in your sky, it'll be tilted about this amount. And you'll have some dark features kind of slashed across here. And this will be the south polar hood, a little fairly bright little cloud up there. You might see a little sliver. Dan saw it last night, I guess, the Tranny and Joyce, of the south polar cap, north polar cap actually shining through. And these have Samarium and Cerberus. They're named after really, God of War. Cerberus, isn't that the three-headed hound of hell that sits there waiting? It's just bad stuff on Mars. Yeah, it's just not good. And but if you wait till 9:30 tonight, wait till 9:30, Syrtis Major will be rotating onto the limb, and it may, I can't guarantee it. I don't know if Dan Troiani had seen this when you were observing last night, but Syrtis Major is covered with a thing called the Syrtis Blue Cloud at certain times of the Martian year. It's really cool. It's called the Blue Scorpion by the early astronomers, and what it is, it looks iridescent. It's a very pronounced blue. If you use a yellow filter, it turns green, because blue and yellow make green. And you put a little yellow filter up in front of your eye, and as that cloud is on the limb, and it's just a shimmering iridescent green. It's spooky looking, because you say this shouldn't belong on a planet, because the colors are fairly muted. So, okay. I think I'm going to take advice of my doctor here and quit right about now. So, any questions? That's about it.
John?
Yeah.
Excuse me, I have an urgent message for you.
Oh no. What's? Thank you. Couldn't wait. I mean.
Didn't mean to interrupt.
Oh wow. We have an email from Stephen Hawking. It says, okay. That's all, folks. Thank you. Yes, sir.
Anybody, I know that the eclipses on Mars from the moons are penumbral.
Yes,
Has anyone detected any sort of darkening
on the planet.
on the planet?
Yes, yes. They showed, you know, it wasn't that eclipse, but they actually showed a darkening going along the planet. Yeah, yeah. Oh, it's incredible what they're doing up there. And you know, those. I mean, you really got to hand it to the guys who designed these landers. They're supposed to go 90 days, and what, 2 years now? They've gone one Martian year already. So slick. Thank you very much.
Thank you.
All right.